Hi everyone, welcome to chapter 13 where we're going to be talking about how we can nest our loops, so our while loops and our for loops, as well as our different kinds of conditionals like if statements. If you remember from the textbook, we talked about how we can have while loops inside of if statements, inside of for loops, inside of if statements, that are inside of if statements. We have all sorts of really complex logic that we can build into our program. It's going to affect the flow of the computer executing those commands throughout our program, but will really unlock the power of what we're able to do with our programs. So it's a really exciting time in your journey throughout computer science here. It is pretty tricky sometimes to wrap your head around what's going on in the programs. So we'll walk through some examples, we'll practice tracing through some programs, and then you'll get lots of practice in your assignments and in your labs on doing this yourself and figuring out, okay, here's a problem and how am I going to use all of these different tools I have and all of the different ways I can nest them together to solve this problem. So in this first exercise, we have 3 different examples that we'll go through, and we're asked to determine what the output will be. So in this case, what's printed to the console. And so what we're going to do is we're going to trace through the program and look at it line by line, just like as if we were the computer itself. So whenever a computer is going to be given a Python program, it'll start off here on line 1. And it's going to start going all the way through each of these lines from top to bottom. The first couple lines here are things that we've seen before. So those are just variables that we've defined, and we're giving them some string values here. From line 6 down, this is a big nested if statement that has one else command in it. And so what the computer will do is it's first going to read in all this information about these variables and be like, okay, I know I have these 3 variables and I know that they have these 3 values. Now we're going to jump to this if statement, and it's going to say, okay, is the value that's stored in bandana equal to red? And in this case it is, so this is going to evaluate as true. And that means we're going to jump in and start executing the body associated with that if statement. So that's everything that's nested underneath that if statement or tabbed over. Even though this other if statement here is tabbed over, it's still included in that as part of the body of that if statement. So it will only get looked at if this very first if statement is true. Now that we know that's true, we can move on to the second if statement, and it's asking, is fur equal to blue? Well, in this case, fur is equal to purple, so that's false. Because that's false, we don't execute anything that's in the body of this second if statement, which would be something that's nested further in. We skip to look to see if there's an else that comes after. And in this case, if there was an else associated with this if statement, we would expect to see it right here at the very same level of indentation. But because there isn't, we don't do anything. There's actually no code after any of this, so nothing happens. It'd be very similar to if this very first if statement on line 6 evaluated to false. Maybe we had bandana equal to orange here. None of this other code would get looked at because this was false. So the computer would just skip to the end of that, the body of that if statement. And because there's no else that's over here at the same level of indentation, there's no code that comes after, nothing ends up happening. Now, as a human, when I look at this code, I can see, okay, I have a feeling these 3 if statements here are related to identifying the great cookie thief. And maybe this else statement was supposed to be printed if all of those things weren't true. So there might be a bit of a logical error in this program, and so that's when the computer can still execute it, but the output might not be what the user actually wanted. And we'll see that a lot in our own assignments and as we're developing code. And how we would fix that is we just need to move this else to the same level of indentation as that if statement up there. We could also combine all of these conditions with ands and just put them into one. So often when you see nested ifs, as we mentioned in the textbook, you could combine them into a single condition with ands or ors. And if we did that and then move that over, that would probably give the behavior they actually wanted. But that's not what this question is asking. What this question is asking is what's printed to the console? A whole bunch of nothing is printed, because none of those statements get evaluated. this is our next program, and we're supposed to determine what gets drawn to the canvas. So again, we have a couple variables up here. One is n, one is g, and we're setting the size of our canvas. Those are some things that we're pretty familiar with. Then we jump into a for loop, which we've seen before. So we have our for keyword, the variable for our loop, that in keyword, and then the range function, which produces a sequence. In this case, I've spoiled it a little bit. We are passing in the value of n, which is 10. So that means the sequence we're going to get is this one here that says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember with range, it doesn't go all the way up to the, or doesn't include the number that you passed in. It goes all the way up to it, but not including. So it's off by 1. Then we have an if statement within our for loop. So what's going to happen is every iteration of this for loop, S is going to take a value from the sequence. It's going to start at 0 and it will go up by 1 until it reaches the very last one. So the very first time we'll have S is equal to 0, and it's going to check and see, is S not equal to G? In this case, G is 2. When S is 0, it's not equal to G. So it's going to calculate an X coordinate. That's going to be S times 30. In this case, when it's 0, that will end up being 0. And then it's going to draw a rectangle. Now, what we're doing effectively in this if statement is drawing rectangles along the very top axis of our canvas. So the very first one is going to end up being here. And they're really more like squares because they have the same size variables or size dimensions. And then we're going to be moving it over by 30 every single time. And you can tell our size is 30, so they'll probably end up looking like a little bit of a grid. And after we execute that first one, we go back up to the for loop, and then S becomes 1. And we check this if statement again. Since it evaluates to true, we draw the next rectangle. And then S becomes 2. We check this if statement, and hey, it's false. Since it's false, none of the body of this if statement is executed, and we just go back up to the for loop and we take our next value for S, which is 3. We check our if statement, it ends up being true, so we skip over that one space and then we draw another square. And that's going to continue for all of the rest of the values in that range, including 9. So we should end up with actually 9 squares. The only one that would be missing is the one that we would get the third one in there. And so you can put that into your processing program and try running it yourself if you want to convince yourself that that's true. Here's our next program. So this is a very, very common type of program that we have. We have just setting up our size here. And then we have this nested for loop. Nested for loops are so common in computer science. You're going to get so much practice with them. And it's good to kind of figure out how these types of loops actually work. So what happens is we have a range that's going to make a sequence of 10, which is this one up here. And we have this range which will make a sequence of 8, which is this one down here. I just did that ahead of time so you didn't have to watch me type all of those numbers. But the value for R is going to be drawn from this bigger range, and the value from C will be drawn from this smaller range. And then it's going to be making a bunch of squares again. So the very first line that gets executed is this one R here. So R is going to start off with a value of 0, and then it's going to jump into our next for loop, which is C. And C will start off with a value of 0. And then we'll be drawing the square, so we have it slightly off from the initial values that were given. So we're multiplying things, and we're, again, making it size 30 by 30. So the very first one, because this is 0 and 0, this will end up being 0 and 0 for X and Y, and then we get 30 and 30. So we'll get a square right up in that top corner. Once that's done, we don't jump all the way back up here. We have to finish this inner for loop before we take the next value for R. So R stays at 0 and C gets updated to a value of 1. So we'll have our rectangle for C times 30, which in this case would be 30. So that's going to change our X coordinate. So we'll move it over here. But our Y coordinate R is from our outer for loop. So that will stay at 0 because we have a 0 times 30. And so it's going to draw a square right here. And again, we don't jump back up into the outer for loop. We have to finish that inner for loop before we would start a new value of r. So c then becomes 2, and we get another square, and then 3, and so on until it gets all the way up to 7. Once we get it up to 7, and we'd have, I think, 8 different squares drawn here. I only have 5, 6, 7, 8. Please excuse my squares at the end there. They look more like cartoon teeth, but that's okay. Once we've gotten, so our C is at our last value in that sequence, that's when we go back to the outside for loop, and then R becomes a value of 1. And what that's going to do is it's going to go through that inner for loop again, starting at 0 and then all the way down to 7. So it's going to draw another 8 squares. You can see I'm getting lazy with my square drawing all the way across that row. And what this ends up making is effectively just a grid of squares that should be 8 across and 10 deep. And you can type that in and try it in your processing program if you would like. But what we're actually going to do is take this and modify it ever so slightly to solve exercise 2 here. So the other one was effectively making a full grid. So all of this gray spot would also have squares. What we want to do is only make it so that there's a diagonal of squares. So half of our grid is full of squares. And we can do that using the almost exactly the same nested for loop. And that might be hard to believe, but I promise you it is true. So very first thing I'm going to do here is just set up my canvas. We'll make it slightly smaller just to reflect the fact that we're not doing a huge 8 by 10 grid like we were before. We only have 1, 2, 3, 4, 5 squares. 1, 2, 3, 4, 5. Okay, and then we know we're going to need at least one for loop. Now, one thing I want you to notice, and this is one of the things that we're going to have to start to try to get really good at as we are programming, is figuring out what is the pattern here. So if we take a look at this, we have 1, 2, 3, 4, 5 squares, but it looks like we could almost have a 6th square there. And even when we go across, we know we have 1, 2, 3, 4, 5 squares. And again, it looks like we could have a 6th square there. So instead of it filling up all the way, it looks like it's at least 1 short here, 2 short for the second column, 3 short for the third column, 4 short for the fourth column, 5 short for the fifth column, and 6 short for the last column. And you'll notice that's a really nice sequence that we can leverage. And that's exactly what we're going to do with our for loops. So we know it has to be at least 6 across, right? So we're going to make a range of 6 to start off with. And that's going to give us our starting point that we have here. So remember on our other one, our range of our outer for loop gave us the number of rows that we had. And in this case, we have 1, 2, 3, 4, 5, 6 possible rows, but it just looks like we skipped that first spot. And we'll figure out how to do that in a minute. And then our inner for loop is going to be the number of columns that we have. So we're going to say if we were doing a grid, it would be C in range 6, right? Because we had 6 columns and 6 rows. And then if we did the same code, we would have our rectangle with our C times 30. This is just the exact same that we just saw in our last one. It's just a bit smaller. And if I run this, we should be seeing our beautiful grid. Ta-da. So now we just need to figure out, okay, well, how do we modify this so we don't get all of this grid, we only get half of it? Right now, and you'll learn more about this in your other first year computer science courses, but we have 2 independent loops that are nested. So there's no dependency on variables from the outside loop in the conditions of the inside loop. Oftentimes, if we want to do things on a diagonal, or we have something where we want like half of something to come up, it's kind of a hint that we should think about doing what we would call a dependent loop, so that the number of squares that we're drawing or words that we're printing is dependent on the value we currently have for the outside loop. So remember this range up here, oopsie, why can't I type? Here we go, is going to be 0, 1, 2, 3, 4, 5. If we take a look at those numbers and what we have on our slide here, if we look at the very first row, do we have any rectangles there? No, we don't. So we should probably, and if we look at our second row, we have 1 rectangle, our third row, 2 rectangles, and so on and so on. So we could use the row value or our R value to influence how many rectangles we would be drawing. And to do that, instead of putting a 6 here, all we need to do is put that R variable here. So that means for the very first iteration of this outer loop, when R is 0, the range of 0 is 0, so nothing will get drawn. When R is 1, we'll get 1 square drawn. When R is 2, we'll get 2 squares drawn, and so on and so on. And so this dependent nature of these nested loops is going to give us that triangular shape that we were looking for. And it's as simple as that one change that took us from a full grid to just half of a grid on a diagonal, which is pretty cool. All right, so exercise 3, we have, I think, just 2 more programs that we want to try to figure out what's going to be drawn. And these have a lot more nesting than what we've seen before. So this one has 3 for loops, which is a lot. This part here, we know what it's doing. It's setting up our canvas size. But now we have 3. And yes, we can have as many layers of for loops and while loops and if statements as we need for our program. And how it works is exactly what we saw up here. We start off on the outer one, we get our first value for the outer one, and then we start working from the inside. And the furthest nested loop needs to finish before the computer goes back to the outer loop to get the next value. So in this case here, we have nice small ranges. So we have 0, 1, 2 for each of these. And you can see I didn't prepare these, and I'm making you watch me draw them now painfully. And we have 3 variables. So A, at the very first time that the computer sees this, is going to take on a value of 0. Once it does that, B is going to also take on a value of 0. And then C is going to take on a value of 0. For all of those initial values, all of this information is going to be calculated. So we'll get our X coordinate, our Y coordinate, and then our Z coordinate. And then we're going to draw that circle based on those X, Y's, and Z's. What this is actually going to end up doing is draw a grid of circles in the 2 outermost loops, and then the innermost loops is going to end up drawing 3 circles within that position. So it's a little bit complicated, and I think it'll be easiest if we actually type this one out to kind of see what's going on here. So just change this here from 200 to 200 to 200. Oops. And then let's put in all of our code. For A in range 3, for B in range 3, and you'll see how it's nesting itself over automatically in processing for us, which is exactly what we want every time we press enter. And then all of our calculations for our coordinates. So A times 60 plus 30. Y is going to be B times 60 plus 30. Whoops. Of course, a typo. And then Z 60 minus C plus 16. And an ellipse of X, Y, Z, Z. So now if we run this, will we see what I see? We get our grid of our circles. If we were to take out this loop here, what would happen, do you think? Actually, I'll just comment it out so that we can keep it in case we want it for something else. So let's comment that one out. Let's tab all of these over one. And I want to see if your intuition is correct here. So I'm giving you a little bit of time to think about it. We will fix the one that's relying on that value of C. We'll give it a default value. And we can see what would happen every iteration of our loop. So the very first iteration of our loop, that C value would be 0, right? And we're timesing it by 16. And if we run that, you'll see how it's slightly smaller, all of our circles. Our second iteration of that inner loop, if we had it, this would be a value of 1. And if we run that, we get slightly smaller circles. And then our third iteration, if we run that, even smaller circles. And the reason we couldn't see them is because the outside loops, as they are changing and giving us new values, they were overriding those images. So it was kind of hard to truly see what was actually happening in that program. As you're practicing with your nested loops, sometimes I think it can be very, very helpful to do exactly what we did here. Comment out one of the nested loops and just manually put in those numbers, run it, and see what you get. Sometimes it can also be helpful to put in print statements where you can see what the values of those different variables are on the console. It can be very, very helpful as you work to debug things. All right? Look at all those beautiful sketches that we have. All right, and now we have this one. So again, a nested loop. So that probably means we're going to be doing some kind of grid. These wild conditions, which if you haven't seen them before, might be a little bit confusing. Some X and Y coordinates with an ellipse drawing, and then an else with some more X and Y coordinate calculations and a rectangle drawing. So again, we would start in our outer loop, we would get that value of I, then we would get the value of J, and we'd do all of the values of J, all of those commands before we get the next value of I. What this is going to end up being is a grid of squares from our rectangle command and circles from our ellipse command. Only some of them will be circles and some of them will be squares. It's going to depend on our row and our column numbers that we have. Now, does anybody remember what this fancy symbol is? It's not a percent symbol, it's a modulo symbol. And remember what that does is it returns the remainder of a division. So if we were looking for even values, if you did, for instance, 2 divided by 2, the remainder of that would be 0 because it's an even value. If you did 1 divided by 2, the remainder of that is not 0 because it's not an even value. So oftentimes in computer science, when we're trying to do something only for the even values and then something different for the odd values, we'll set up an if statement like this, where we're saying if some value is even, which we would get by dividing that value or modulating that value by 2 and checking to see if the remainder is 0, then we're going to draw, in this case, a circle. Otherwise, it's an odd value and we're going to draw a square. And so what I'd like you to do is type this out into your own processing and play with some actual values for I and J and see if you can tell, okay, yeah, this is what it's doing when it's even. This is what it's doing with an odd. And you can take a look at the output that produces. All right. This is our final exercise for this. We're going to draw or define a function called layout targets that takes in one parameter called difficulty, which should either be a value of moderate or challenging as a string. The layout of the targets will depend on that parameter, and it's either going to look out like this or this. So the right one is the challenging one, the left one is the moderate one. We have access to a predefined function called draw target by column and row, which will draw a target in the specified row and column. Remember, when we're counting in computer science, the rows and columns will start at 0. So we'd have 0, 1, 2, 3, 4. And same with the rows, 0, 1, 2. And then this side too, 0, 1, 2, 3, with the same values for the rows. So we're going to use this draw target function and some nested loops to recreate those two pictures that we have. So I'll bring over my processing here. I'm just going to get rid of all this code that I have. I'm going to put in the draw target command because I don't think it actually gave it to you on the slide. So draw target, it's pretty easy, pretty straightforward. Takes in two parameters, which are the row and the column. And it's just going to draw an ellipse with some math that we figured out that will space everything out correctly into that kind of like grid-like fashion that we wanted. Oops. So very similar to what we saw in some of those examples. Plus 15, 30, 30. Okay. Then let's draw or get our function where we're actually going to be drawing it. So the function should be called def layout targets difficulty. And then we're going to be doing one thing or another depending on what the value we actually, or what the parameter actually says, right? So if our difficulty that we passed in is equal to moderate, we will do one thing. Ooh. Typing. And then I'm just going to put in my elif for if the difficulty is equal to challenging. Just so I have it there so I don't forget to do it. You don't have to do this exactly the same as how I like to program. If you like things slightly different, you can. I would always recommend doing an elif if we're checking for another discrete value. If we just put this as an else, somebody could pass in eor and it would give us the challenging layout, which might not be what we want. So if we have a moderate difficulty, what I'm going to do is I'm going to set up the number of rows and number of columns that we would need. So in this case, we would need 3 rows and 4 columns for our moderate layout. So I want to just add in a couple, not 4, 5, correct? Yeah, 5. I'm going to add in a couple of variables that just keep track of that information for me. So num rows is equal to 3, num columns is equal to 5. The other thing that is different between the two of them is which row has the red circles. So in the moderate, it's row 1 that has the red circle. So I would like to keep track of that as well so that we can color that appropriately. So red row is equal to 1. And then I'm going to do the exact same information gathering for if it was a challenging setup. So again, we have our num rows, which is the same. Our num calls, which is 4 in this case. And I'm just getting that from the picture. And then our red row, in this case, is row 0. And so remember, when we're labeling those rows, we start at 0. So this one is 0 and the middle one is 1. But when we're telling the computer how many of them, we don't say 2, we would say 3. So it's just a little bit of a quirk with our computer science numbering that we have. Okay. So now that we have that, I'm going to just set up some general for loops that can take those variables and create the layout that we want. So very first thing I'm going to do is set my background here to black, because for either or it needs to be black. I'm then going to make a for loop that's going to first go through and make all of my rows, right? So when we're doing a grid, we're almost always thinking nested for loop. Outer one starts with our rows, inner one is for our columns. So for are in range num rows, and I can't just pass in num rows there. I have to make a range so that it makes me a sequence. And then also I'm just going to automatically, before I do anything else here, make my nested for loop for my columns, which would be for range num columns. So this, if I just did this and I just drew a target using that draw target command we have, is just, it should just draw me a grid of circles. Now let's actually call this function. So remember, we just have all of the information, but we haven't actually called it. So what I'm going to do is down here after the function, I'm just going to try this with moderate, and make sure that your capitalization is the same as what you used in the strings up here for your if statements. If it's not identical, it will evaluate to false. So if I run this, you can see I get some circles. It's going off the side of my canvas, so maybe I should look at setting up my canvas to be a little bit bigger. So I'm also going to just set up my size to be 200 by 200, and then I'm going to rerun that and see if that's big enough. It captures all of mine. Oh my goodness. I think I need to put that into the setup function. Let me see. I think that might be why it's mad at me. Try both those like that. See if that makes it happier. And then it's going to yell at me. And you know why it's yelling at me is because I need a draw command. And so in here is where I'll do my draw. Oh, and I'll put a def. And then I'm just going to have my calling of my function in there. Now if I run it, haha, there we go. It's less mad at me, which I like to see. Now we have that. We need to make those circles blue. So all we need to do for that is before our draw target command, we would have a fill. And remember, with our red RGB colors, we would just say no red, no green, all the blue. And you could pick a little bit of a nicer blue. And now let's see if that will make that beautiful. So I have my grid of my blue circles. But now I need to figure out, how do I specify the row where I would like it to be red? And so what I need to do is, before I'm calling draw target, I need to decide if I should fill it with blue or if I should be filling it with red. And I can do that using an if statement, right? Because we know for each of these conditions here, which one should be a red row. So we just have to compare R to see if it is equal to our red row label. And if it is, then we would fill it only with red. Otherwise, we'd fill it with blue. And we can kind of flip that around. I'm going to do that. So we would say if R equal red call. I think that's what I have it as. Red row. Sorry, red row. Then we're going to fill it with red. Else it's not the red row, then we'll just fill it with blue. And irregardless, after both of those, we're going to draw the target. So now if I run it, beautiful, I get my red row for moderate, and now I'm just going to change this to challenging and see if I get perfect, the output that we wanted for challenging. So you can see how by making this parameterized, so making some variables, assigning them values, and then using a for loop with an if statement in there, I can get the behavior that I want out of my program by just switching a string that I'm passing in, which is pretty cool. This stuff is tricky. So give yourself some time when it comes to things like the assignments. Have lots of time to start working on it, lots of time to attend tutorials and help hours, kind of work through this different kind of logic, try different things. I have been doing this for a really long time, so it's easy for me to look at a nested for loop and be like, yep, that's what's happening. I don't expect you to be able to look at it in 30 seconds and see exactly what's happening in a program, but that's what you're going to be building towards. So don't be frustrated if it takes you a minute to get there. That's what the purpose of this is, but just work on tracing through those programs and come and get help when you need it. We don't want you suffering through a problem by yourself. That's why we have the tutorial and help hours available for you. All right, happy coding.